interested in, position versus time, right? Give me 2 points in the QT space, then how to connect them, how the motion occurs versus time. It happens such that the action integral is minimized, subject to no constraints. I don't care about conservation of energy, it's already taken care of, because now we're talking about Lagrangian, not kinetic energy. So the action integral is the integral of the Lagrangian over time. This is what? What is this? This is the very first problem. It's calculus of variations. So actually, calculus of variations, or the first order necessary condition for this guy is what? The first variation of the action integral is 0, which is using the calculus of variation gives you what? d by dt, partial L, partial Q dot. What Q? Every Q you have, right? Minus partial L, partial Q is 0. This is indeed Lagrange's equation that we have been dealing with. It really comes from calculus of variations, right? So if you go next year and take the prelim exam, and I ask you about the principle of least action, do not claim that you did not see it. Okay? Just, this was the week of prelims, and I mean, I didn't change anything from last year. Lecturing is the exact same thing, and they claimed that they didn't see the principle of least action. You can see how much time we spend with calculus of variations.
So you mean to say that this calculus of variation was presented in the final form by Hamiltonian rather than Lagrangian?
Yes, Hamilton. So Hamilton is the first one to formulate the principle of least action in the standard form that we know nowadays. This is the standard form of the principle of least action. If you Google it, this is what you will find. And it's very useful because it's in the TQ space. This is what we're really interested in, is to know how the motion occurs versus time, not how the motion occurs in the Q space. Okay? Just to give you a little bit of idea about the difference, if you are here in the XY, for example, and you do a projectile, okay? There is a difference between I get X as a function of time and Y as a function of time versus I get the trajectory, Y as a function of X. Okay? So this is the difference. And this is unconstrained. It doesn't require conservation of energy. This is constrained. So Hamilton indeed is the one who set the principle of least action. It's current format, and it's not minimum. It's stationary. It might be maximum in some other motions. So the very exact statement of the principle of least action is that between two specific endpoints, I have to have specific endpoints. Remember one. Between two specific endpoints in the QT space, the motion is such that the action integral is stationary. It's not necessarily minimum. The action integral is stationary, i.e. the first variation is 0. And if the first variation of some integral is 0, calculus of variations immediately tell us Euler-Lagrange equation, or Lagrange's equation. Okay? So if I ask you in the homework, final, prelim, whatever, get the action integral and use calculus of variation to minimize it or whatever, it's simply I'm asking you to just write down Lagrange's equation. This is exactly Lagrange's equation. We're not doing anything else, right? Kinetic potential Lagrange. Any questions so far? So this is how this is related to dynamics. Finally, we know how optimization is related to dynamics. It's simply the nature is optimizing the dynamics of particles. So they are related. So Newton equation, in a sense, Newton equation F equals ma is equivalent to minimization of kinetic energy, right? Any questions so far? Any question?
There's a reason why the mv squared is the most fundamental quantity, because that's the most fundamental quantity for motion. Why is it just mv squared, not like all the potential energy, or like everything?
Potential energy is really taken care of here, but I don't know why it's mv squared. If you want to propose mv4 and we can.
No, I mean like.
No, seriously, I'm really serious. This is And this is why I propose it this way. These things are not very legitimate. Okay? They are not very legitimate. F equals ma is an assumption, it's an axiom. Newton himself said this is axioms, 3 axioms. This is the second axiom. And again, this is a principle. Nothing here is that, say that these are
Theorems.
okay, and this is why, yeah, the principle of least action itself has to be modified. I mean, not modified. The principle of least action works for relativistic mechanics in the very large scale. But the Lagrangian will be a little bit modified, okay? Because the physics is a little bit modified over there. Because of the dilation of time and this kind of thing. We will touch base on that at maybe the last lecture after we get the geometric mechanics. These things are not legitimate. If you really want to propose something else, if you want to propose here that F is not ma, F is constant times acceleration plus constant times velocity plus constant times maybe the jerk, which is the derivative of the acceleration, let's do it, okay? And you will just flip the entire planet. Because you can imagine, we design this guy, that guy, airplanes, submarines, we design cars, we design space shuttles, we design airplanes and drones, and every single machine here based on F equals ma, right? And we know that it doesn't work for very large scales, it doesn't work for very small scales, and we know that it's a hypothesis, it's an axiom, so it's very critical, right? If you bring something else that is as good as Newton's equation, then it would be just flipping the table. Okay, we have a bit of time. I'll give a quiz for sure. It's an easy quiz, but we even have still a bit of time before giving the quiz. Do you have any questions so far? We finished the calculus operations. Next time it will be again, and I will say it for the last time. It will be completely new thing. Do you have any questions? Please. Do you have any questions? Simone. Yes, please.
Where do we account for the non-conservative forces in Lagrange? Because Lagrange doesn't.
Say it again, please.
Where do we account for the non-conservative forces?
We cannot. They have to come on the right hand side. We cannot take it here. Yeah, let me add one thing here. Let me add one thing. Yeah, I did not. So we learned the principle of least action, right? We learned the principle of least action, which is equivalent to Lagrange's equation. That's fine. But what about if I want to minimize A, which is T naught T1, some Lagrangian, our Lagrangian function, not some. But now it's subject to some holonomic constraint. Right? This is a holonomic constraint, correct? So, what do you think?
Same use from the augmented.
It's this guy, right? It's finite potatoes. So that's perfectly fine. This is A, I'm gonna call A Lagrangian or whatever. It's just the integral of what? L plus lambda epsilon, correct? D and lambda is function of time. And what's your first order necessary condition? Is the first variation of this guy is 0, which through calculus of variation is d by dt. Partial, whatever here, partial your q j dot, right? Minus partial whatever here, partial q j is 0. So psi, because it's a holonomic constraint, it doesn't depend on velocities. So partial psi, partial q dot is 0. So I have here d by dt, partial L, partial q j dot, minus partial L, partial q j, and I will send this guy to the right hand side, which is lambda has nothing to do with q, so here is lambda, partial xi, partial qj. If you remember partial xi, partial qj, this is what we call the AKJ. If psi is the psi k, right? This is psi k, this is psi k, this is psi k. The k constraint, because maybe you have many of them, right? This is AKJ, and this is the term in the right hand side due to the constraints that we know. It simply comes from calculus operations in a straightforward way. Okay?
How do we deal with the non-holonomic constraints under such environment?
So this is the thing. If you have non-holonomic constraints, or if you have a polygenic forces, then you lose the variational thing.
There is no way.
So you cannot write your equations of motion as the first variation of something equals 0, or the motion is minimizing something. Okay? But you still use the same formulation, because what we discovered is that it's the exact same term for either holonomic or non-holonomic. Okay, here is your quiz. It's a very easy one. You need anything else? X dot square over t cube from 0 to 2, x0 is 0, x2 is 16. Find x star that minimizes this guy. Answer. Is Patricio here? I have problem for homework 2 for somebody. Problem for homework 2. Okay. Can you give me your homework? Well, I'll pass it to the homework.